Hello all, welcome to Code Hub. Today let us see the let us solve the LeetCode daily challenge. And the problem is best time to buy and sell stock for. This is a hard tag problem and it may need a prerequisite of recursion and dynamic programming. So let us jump into the problem statement. The problem is nothing but you are given an integer array prices where prices of I is the price of a given stock and the on the ith day, and an integer k. They have given a prices array and an integer k. We have to derive what is the maximum profit you can achieve if we do at most k transactions. So the one transaction is nothing but one time we buy and then sell does this buy and sell means one transaction, so that we can do at most k times k transactions. So you may not engage a multiple transactions simultaneously, that is you must sell the stock before you buy again. So once we buy only we can sell, or once again we want to buy means we have to sell the previous stock. So that is the problem statement. It is quite explainable problem statement, but this may require a complex implementation because we have k transactions and we can use at most k transactions. We may not know we may not know whether we get the optimal answer in one transaction or two transaction, or if k grows up to what is the range of k is grow up to 100. And if we take one if we buy this item, then we have to sell this item such that the profit is 6 minus 3. And if we buy this item, then we sell this at 6, then the profit is 6 minus 2 4. So we may not know we may not know the where will be the profit occurs, and there will be many possible solutions. And since there is many possible solution and we may want to find the maximum profit, we tend to go for dynamic programming, that is the recursive approach. Why so? Because we cannot assure that the current decision that we are taking may lead to optimal answer or may not lead to optimal answer. So we are not sure of that current decision we are taking. So we cannot approach this in a greedy fashion. So we are trying to explore all possible ways. How we can explore all possible ways? We can try to express this array as indices first. So the prices array we can see as each position we can represent it as POS, and there are at most k transactions. And also we want to know whether this item is buying or with this item is selling. So that is, we have to now buy this item or we have to now sell this item. So we want to know what is the decision that we are going to take at this current position. So let me name it as to buy. This to buy is nothing but this is going to be a flag variable where one denotes we have to buy the item now, and 0 denotes we have to sell the item now. So here since we want to explore all possible ways means we have to go for pick or not pick case. So but how we are going to implement this pick or not pick case in this decide problem? Let us see how we can do. Let us take this example 2 4 1. Here what I am doing is I can either pick this 2, that is I have buyed this 2 and then I can move to the next item, or if I don't want to buy this 2, then I want to skip this item. I am just skipping. This is buying, this is skipping. That is ultimately nothing but pick and this is not pick. So if we buy this item 2, then we tend to move to the next position, and this 4, we have already buy an item. This 2 buy is a flag variable which denotes we have buy an item. So now we want to sell this item. While we are selling this item, we have to subtract that value with the previous value. We have to subtract this previous value with this current value. So we know that the profit is 4 minus 2, which is 2. So what we can do is, we can while we are buying the item, we can call the recursive function, and then what we can do is, we can just decrement this prices of I. And when we are selling this item, this is buying case, and when we are selling the item, what we can do is, we can add the prices such that when we solve the recursive problem, this value is going to decrement, this value is going to be subtracted, and this value is going to be added, and ultimately we are just adding prices of I minus prices of previous value. So which is ultimately we will be getting the profit 4 minus 2, like 6 minus 2, like 3 minus 0. Like this we can do this recursive function. So we are actually approach the problem. Let us try to code this approach with our observations. We are actually having 3 variables. These are the variables, these are the parameters that we are changing. We can have a size n, prices dot size, and I'm going to call this recursive function. This recursive function I will name it as solve, and here I'm going to pass the prices array. Then I will be passing the position, then the k, and also a flag variable which is initially 1. That is, I'm going to buy first, and then only I can sell it. So this is a private function. This is going to return me an integer variable, and this is the parameters are vector int prices, int position, int k, and int to buy. So let us come to base case later. What will be the base case? Before that, what are the two cases? Either we want to buy the item, either we want to sell the item. So we can decide. See, we can decide with that boolean variable. So let us have it as bool. So let us pass it as true. So if this is to buy, that is, if initially this is true, that is, we have to buy this item. We have 2 options. Let me have 2 options. Option 1 which is 0, option 2 which is 0. So when we have to buy the item, there are 2 options. Either I can buy this item. While buying this item, we are tend to decrement the prices of I. So option 1 is nothing but minus prices of I. That is, we are decremented the prices of I plus this recursive function. Since we have to explore other possible ways. How we are going to explore other possible ways? The position will be moved to 1. It will be moved to position plus 1, and k will be remaining the same because we have not yet made one transaction. The one transaction means we have to buy and sell an item. We have to do both, then only we can reduce our transactions. Once we have buy the item, we have to toggle this boolean value also. So we can make it as, we can toggle the to buy boolean variable by not of to buy. Option, what will be the option 2? Option 2 is nothing but we can skip this item. That is, not pick case. This is pick case. This is pick and this is not picks. While not picking the case, what we have to do is, we can just write the recursive function prices of I, and the position will be moving to the next position, and k remains the same, and we don't want to toggle this to buy variable because we have not yet buyed any item. So we are just skipping this current item. So if this is selling, if this is this case lies where we want to sell the item. How we can sell the item? There also appears 2 cases. Option 1 is nothing but pick case. While picking case, what we have to do is we can sell the item. How we will sell the item? We can include this prices of I. That is, we can prices of I, not it is prices of position. Prices of position. Prices of position we have included. We have added this prices of position plus the next possible recursive solution. We have to go to next index and k. Since we have picked, we have bought an item, we are also selling the item, so we have done one transaction, so our transaction k minus transaction will be decremented by 1, so it becomes k minus 1. So once we have sold the item, we have to toggle the case, toggle the variables, so that we can next buy the item. So now the not pick case, if we are not picking the case, that is we are not selling the item currently. If we are not selling the item currently, then we can skip that case. So we can pass on to the next position and k remains the same, and we are want to sell the item, so the to buy variable remains the same. We have written all the cases. Now we have to return both the maximum of both the options. So this will be our conditions, but what will be the base cases? Our base cases is nothing but if my position is reaching our size. Let us have another variable in n. We can pass this n as well. If my position is reaching the size of the prices array, or my k has become 0, then we can just return 0. This will be my base case, right? If my position is reaching the end of the array, we can't buy or sell the item. If my k is 0, we can our transactions, utmost transaction is completed and it is exhausted, so we can return 0. So this will be our recursive solution. Let us try to run our code. Once it is run, we can try to memoize it. Okay, yeah, we have to pass on this n as well. We get the correct answer, but anyway, this will not give us accepted, because we will be trying out all possible solution. On all possible ways, it can range up to 2 power, it can go exponentially. Since we are taking for each and every index, we are taking either pick case or not pick case, it can grow exponentially. So what we can do is we can just memoize it. How we can memoize this? We want to see what are the changing parameters, how many number of parameters are changing. There are 3 parameters that are changing: position, k and to buy. So we can declare a 3D array, 3D DP array, vector of vector int, vector of vector of vector int. Here vector of vector of vector int, what we are doing is we have declared a 3D dimensional array dp, where the size of this first dimension is nothing but n, and the size of the second dimension is nothing but vector of vector int k plus 1. Since we are using k and we may require k transaction as well, so we will be handling one based indexing in k, so we will have k plus 1. And the third dimension is nothing but only two cases, either 0 or 1. So either 0 or 1, so we can just declare the size as 2, and we can initialize everything to -1. So we can pass this dp as well here, and to every function we can just replace this dp. And then this dp should be passed also. And we have to memoize it, dp of position, k and to buy. So we have just memoized it. What if the subproblems are already solved? We want to check that case as well. If my dp of position, k and buy is not equal to -1, just return me this dp of position, k and to buy. So now let us try to run our code. and see whether we are getting accepted. Yeah, it got accepted. So we have memoized it. So let us try to submit our code as well. Wonderful, it got accepted. Hope you like this video. We have done the recursive solution, then we have memoized it. So the time complexity here will be order of n cross k cross. We can either consider into 2 because we have a flag variable as well. So the space complexity will be also n into k into 2. So this is the optimal solution that we can tend to say in our interviews. So I hope you like this video. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.